Welcome to Mr. Tompkins Ed Tech. Maths Paper 1 is days away, and if you're sitting the AQA or Edexcel exam boards, that means you have a non-calculated paper to do this coming Thursday. In this video, I'll identify the top 10 most likely topics you'll encounter on a non-calculated paper and run through some of the typical exam questions to help you prepare for that paper 1. If you're sitting OCR, then this video will be great preparation for your paper 2. So come back once you've done paper 1 next week. There is a worksheet that goes with this video, and I strongly recommend that you try the questions first yourself before watching. You can then mark it and up-level your answers and identify any weaknesses or misconceptions that you still might have. Also, in the description underneath the video, I've put links to further videos and worksheets on each of these specific topics. That way you can delve deeper into any topics that still need further work. If you find this video useful, please give it a thumbs up. That really helps me out. Once paper 1 is out of the way, I'll be posting more videos covering paper 2 and 3, so make sure you're subscribed with a bell notification turned on so you don't miss out on those. Any further questions that you might have, just write them in the comments below the video and I'll try to answer them for you. Now, the non-calculated paper is the only opportunity to test certain non-calculator skills, which means these topics come up nearly every paper. So the topics we'll be looking at today are algebraic expressions, substitution, solving equations, sequences, percentages, indices, inequalities, standard form, and calculating exactly with pi. Now, if you're solid on all of these topics, you should be looking at a very respectable grade for this paper. Now, if you haven't already downloaded the worksheet yet and given the questions a try, I'd suggest you pause this video now and do that first. You'll find the link to the worksheet in the description below the video. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. Right, I've got the worksheet? Good. Let's move on to the first topic. First up, let's take a look at algebraic expressions, and question 1 asks, circle the expression that is equivalent to 4 times x. Well, 4 times x, that's just 4x, isn't it? It's that one there. Circle the expression that is equivalent to y times y times y. Well, if you multiply something by itself, you square it. If you multiply something by itself 3 times, you cube it, don't you? So y times y times y is going to be y cubed, is that one. And circle the expression as equivalent to a plus b. Well, b plus a is, isn't it? It doesn't matter which way around you add things. B plus a is the same as a plus b, it's the same as 2 plus 3 is the same thing as 3 plus 2. It's not the same as multiplying them together, and certainly it's not the same as multiplying them together and doubling it. So yeah, it's just b times a, b plus a. Question 2, simplify 7x plus 5 minus 8 minus 3x. Okay, so here we're going to have to collect like terms together. I've got a term in x here, 7x, and I've got another term in x here, minus 3x. Now notice I'm kind of including the sign in front of the term when I colour it, and I've got two number terms, haven't I? Plus 5 and minus 8. Okay, so 7x minus 3x, that's 4x. So 7x minus 3x is 4x, and 5 take away 8, that is minus 3. Okay, so it's yes, that one. Question 3a, simplify y times y. Yep, so when I multiply something by itself, I square it, so that's going to be y squared. Simplify 5a plus 2 minus a plus 9. Like terms are 5a and minus a, and I've got some more like terms in 2 and plus 9. So combining the 5a minus a, that's going to give me 4a. And combining the plus 2 plus 9, that's going to be plus 11 then, isn't it? Okay, so 4a plus 11, that's my final answer. Question 4, simplify 7a plus 5b plus 3a minus 2b. Again, I've got terms in a, 7a and 3a, and I've got terms in b, 5b and minus 2b. So combining the a's, 7a plus 3a, that's 10a, and combining the b's, I've got 5b take away 2b, that's 3b. Okay, so 10a plus 3b is the final answer for that one. Question 5, match each expression in column P with the equivalent expression in column Q. One has been done for you. Yeah, so a squared times a, that's a cubed, isn't it? Now 2a times 3, so we've got two types of thing here. We've got numbers and letters. And when you multiply these things together, I kind of just multiply like with like. So 2 times 3 is 6. This is going to be 6a. So it goes with this one. 12a squared divided by 2. Again, we've got like our a squared, which is one type of thing, and then we've got 12 and 2. So I'm going to divide the 2 into the 12. 12 divided by 2 is 6. That's 6a squared then, isn't it? That's the one down here. And finally, 10 times a half a squared. So I've got my a's here, and I've got my number parts. So 10 times a half. I'm going to multiply the 10 and a half together. That gives me 5. 5a squared then altogether. It's that one over there. Okay, and then this 5a is billion mates over it. It's got no one to join up with. Question 6a, simplify fully 7a plus 3a minus 4a. Now these are all like terms, aren't they? They're all the same, a. So just add the 7a and the 3a first. That gives me 10a, and then take the 4a away. That's going to give me 6a. Simplify fully 3 times m times 2 times p. So we've got two numbers, we've got an m, and we've got a p. So if they're the same, we can kind of multiply them together. If they're not the same, we just kind of push them up against each other in the final answer. So the 3 times 2, that gives me 6. And then I've just got an m by itself, so I'm going to write m. And I've just got a p by itself, so I'm going to write p. Okay, so the final answer is 6mp. Question 7, match each expression on the left with one on the right. One has been done for you. Yeah, 12ab divided by 4. So like I was saying earlier, I've got a 12 and a 4, so I'm going to divide those. And I've got an a and a b, so they just stay as they are. So the 12 divided by 4 is going to give you the 3, and then we've just got the a and b that we had to start with. Okay, a plus a plus a plus a, that's 4a then, isn't it? 4a is when you've added them all together. So these are all like terms, so we can just add them all up. That's going to be 4a. 4 times a times b. These are all different things, aren't they? I've got a 4, which is a number. I've got an a, which is an a, and I've got a b, which is a b. So they all just end up being pushed up against each other. It's going to be that one up there. A times a times a times a. When you times it by itself, you square it. Times it 3 times its cube. Times it 4 times. That's a to the power 4, isn't it? It's that one. And a plus b plus b. I've got two terms in a that I can add together. I've got two terms in b that I can add together. So a plus a is 2a, b plus b is 2b. So that is 2a plus 2b is that one. Question 8, simplify 12x squared minus 8x squared minus 5x plus 2x. Now, all the terms have got x in, but some are squared and some are just normal x's. So if they've got a square in it, they're a different type of term from the singular x's. Okay, so I've got two types of term here. I've got terms in x squared and I've got terms in x. So I can combine the terms in x squared. 12x squared minus 8x squared, that's 4x squared, isn't it? And the minus 5x squared plus 2x, if you start at minus 5 on the number line, you add 2, it's going to take you up to minus 3. So that's going to leave me with minus 3x there. So that's what I get, 4x squared minus 3x. Question 9, simplify fully 2 lots of 4a plus 9 plus 15a over 3 minus 7. Okay. So I've got a bit of work to do here. I'm not going to bother to try and collect like terms first. I'm just going to simplify the various parts of my expression first. So I've got 2 lots of 4a. 4a and 4a make 8a, don't they? So 2 times 4a is going to give me 8a. Then I've got my 9. 15a divided by 3. Well, 3's go into 15 5 times, don't they? So that leaves me with 5a. And then I've got minus 7. Okay, now I've got it looking a little bit easier. Now I can start collecting like terms. I've got terms in a and I've got numbers. So collecting the A's together, 8A plus 5A, that's 13A. And collecting the numbers together, 9 take away 7, that is 2. So my final answer is 13A plus 2. 13A plus 2. Moving on to substitution, question 10. P is equal to 2A plus 3B. Work out the value of P when A is equal to 11 and B is equal to 5. Okay, so P is equal to 2A, but A we know is equal to 11. So that's 2 lots of 11 and plus 3 lots of B, but we know that B is equal to 5. So I'm going to replace that B there with the value 5. So that's 2 lots of 11 plus 3 lots of 5. 2 times 11, that is 22. 3 lots of 5, that's 15. Add them together, that's 37. My answer is 37. Okay, so I just plonked in the 11 value there and the B value of 5 in there. Question 11, work out the value of A squared minus 4A when A is 10. Okay, so I'm replacing A in 2 positions this time. So my value of A is equal to 10 is going to go here and it's going to go here. So first, A squared becomes 10 squared minus 4 lots of 10. Okay, so replacing the A in the A squared and replacing the A in the 4A gives me that. Okay, then let's just deal with what we got then. So 10 squared, that's 100, and then minus 4 lots of 10, that's 40, and 100 minus 40, that's 60. So that's my final answer, 60. Question 12, work out the value of 4 lots of 2x plus 3y when x is 8 and y is minus 3. Okay, so we're going to replace x is 8 here, and we're going to replace y is minus 3 in here. Okay, so just writing out everything as it is without working anything out. 2 lots of 8 plus 3 lots of minus 3. Now I do recommend you just do this, what I'm doing here, just replacing the letters with the numbers. This is a 2-mark question. That's the first mark in the bag. Just replacing the letters with the values before you do any calculation, because if you make a mess of the calculation now, at least you've got one of the 2 marks. Okay, right, so let's resolve what we've got here. So I've got 4 lots of, but I've got 2 times 8, 2 times 8 is 16, plus 3 lots of minus 3, which is minus 9. Okay, so that's 4 lots of 16 minus 9, but 16 minus 9, that is 7, isn't it? So I've got 4 lots of 7 in the bracket, and 4 lots of 7, that's equal to 28. That's going to be my final answer. Question 13, P is equal to 2L plus 3W minus 6Y. Work out the value of P when L is 5, W is 4, and Y is a half. Okay, so we've got 3 things to plug in this time. L is 5 is going here, W being 4 is going here, and Y being a half is going in here. Okay, so my expression for P is equal to 2 lots of L, 2 lots of 5, plus 3 lots of W, that's 3 lots of 4, minus 6 lots of Y, which is 6 lots of a half. I don't know if you notice, I always substitute into brackets. I just find it easier to see where I'm putting the numbers in. They don't really serve much in the way of mathematical function. It's just to make it really clear and visual where I'm subbing the numbers in. Okay, so then once we've got the numbers in, then we can work them all out then. So 2 times 5, that's 10, 3 times 4, that's 12, and minus 6 times a half, half of 6 is 3, that's going to be minus 3. So I've got 10 plus 12 minus 3, 10 plus 12 is 22, take away the 3, that's 19. That's my final answer. Question 14, here are 3 expressions. When A is 2 and B is minus 6, which expression has the smallest value? Okay, well, if A is 2, it's going here, it's going here, and it's going here. And if B is minus 6, it's going here, it's going here, it's going here. Let's work out the value of those 3 expressions then. So B over A, that's going to be negative 6 divided by 2, subbing in for A and B. Minus 6 divided by 2, 6 divided by 2 is 3, minus 6 divided by 2 is minus 3, so that's negative 3. Now A minus B, that's going to be 2 minus negative 6. 2 minus negative 6 is the same thing as 2 plus 6, and that is the same as 8. Okay, so it's definitely not that one because minus 3 was the smallest. And then so far, but then I've got A, B to evaluate. A is 2, B is minus 6, so subbing those in and then multiply them out. 2 times negative 6, that's negative 12. Okay, so which is the smallest value? The smallest is going to be the most negative in this case, isn't it? It's going to be the negative 12. That's the smallest one. Next up, solving equations. Question 15, solve 7x is equal to 56. So when we're solving an equation, we're trying to get x by itself, and we're going to do that by using inverse operations, kind of unwinding the expression to get back to x. So at the moment, I've got 7 times x is equal to something. If I want to get x back again, I have to do the opposite of times in x by 7, and the opposite of multiplying is dividing. So I'm going to divide both sides by 7 here, and as long as I do the same thing to both sides, the equation stays balanced. So 7 divided by 7, they're going to cancel. That's going to leave me with x on this side. And 56 divided by 7, well, 8 7s are 56, aren't they? So that's going to be x is equal to 8. X is 8. Solve n plus 7 is equal to 103. Here I've got the value of n, and 7 is added to it to get my answer. So to get back to n, we need to do the opposite of adding 7, and that is subtracting 7. So if I subtract 7 to both sides, stays balanced, but this will disappear, leaving me with just n on the left. 103 take away 7, that's 96. That's my final answer, 96. And B, solve m divided by 6 is equal to 12. So I had the value of m, I divided it by 6 and I got 12. So to get back to m, I need to do the opposite of dividing by 6, and that is multiplying by 6. So as long as I multiply both sides by 6, it should stay balanced. But that 6 will cancel with that 6, and it will leave me with m on the left, and 12 times 6, what's that then? Well, 5 12s are 60, so 6 12s is going to be 72. M is 72. Question 17, solve 25 minus y is equal to 18. Now this one's a little bit more tricky because the y is negative here. We want y is equal to something, not minus y is equal to something. So it's a bit of a trick. I think the first thing to do is, if you get a minus y like that, and that's the thing you're trying to evaluate, if you add y to both sides, then this minus y will cancel with this one, and I'll get y plus 18 on the other side. And then I've got a positive y that I can then deal with, 18 plus y. Okay, so then if I want to get y by itself, then I'm going to subtract 18 from both sides. That will cancel with that, and then now I've just got a y on the right, and then 25 take away 18, that's 7. So 7 equals y, that's the same thing as y is equal to 7. Question 18a, solve x plus 12 is 29. Now, if I've got x and I added 12 to it and I got 29, if I want to get back to x, I need to take the 12 off again. So taking 12 off both sides, that's going to give me x is equal to 17. Question B, solve 0.5y is equal to 20. Well, 0.5y is like half y, isn't it? Half of y is equal to 20. Now, how can I get y back from half y? I need to double it, don't I? So, and this one, I'm going to have to multiply that side by 2 to get y again. And if I multiply that side by 2, I've got to do it this side as well. So my 2 and my 0.5 cancel. And that leaves me with y on the left. And my 20 times 2, that's 40. So y is equal to 40 is the solution. Now, when we move on to question 19, this is slightly harder because we've got two things that have been done to x. My value of x has been multiplied by 6, and then 11 is subtracted from it, and the answer is 13. So we have to move the 11 and the 6 away from the x, but which order do we do it in? Okay. Now remember, we're using inverse operations. We're kind of working backwards here. BidMaths would normally tell you to do the multiplication first and then the subtraction, wouldn't it? So the multiplication is here, times in by 6, and then the subtraction is the minus 11 part, isn't it? Okay, so if I was evaluating it, I would do the multiplication and then I do the subtraction. But I'm not trying to evaluate. I'm trying to get back to x. And kind of what we end up doing is we kind of work through BIDMAS backwards when we're solving an equation, and we do the rearrangement in the opposite way that we would evaluate x. So if we're going to be multiplying by 6 first and then subtracting, to get back to x I have to do the opposite of that. So rather than subtracting 11, I'm going to be adding. So I'm going to do the adding 11 first to both sides. That will cancel with that, leaving me with the 6x. On this side, 13 plus 11 is 24. And then the next thing we're going to be doing is we're going to get rid of that 6 in front of the x by dividing both sides by 6. That'll cancel, leaving me with the x. And then 24 divided by 6, that is 4. So x is 4 as a solution. Okay? Same deal with this one. I've got 10 times x minus 3 is equal to 21. So it's exactly the same format as the one above. I've got a number times, x is times by a number, and then 3 is subtracted. So if I want to do inverse operations, I'm going to move the subtraction first by doing the opposite, adding 3 to both sides, cancelling that, leaving me with 10x on this side and 24 on that side, and then I'm going to divide both sides by 10. Okay, that will cancel with that, leaving me with x, and x is 24 divided by 10, that is 2.4. Question 21, I've got x divided by 3 minus 9 is equal to 12. Again, we're going to be using BIDMAS backwards. BIDMAS backwards. So what have we got here? We've got a division and we've got a subtraction. So doing BIDMAS backwards, we're going to do the subtraction first. We're going to do the opposite of the subtraction. So rather than subtracting 9, we're going to be adding 9 to both sides. That will cancel off with that. It will leave me with x over 3 is equal to 21. And then we're going to deal with the division. So we want to do the opposite of dividing. The opposite of dividing is timesing. So multiplying both sides by 3. That will cancel with that, leaving me with just the x on the left. 21 times 3, that is 63. Okay, next one up, 4 lots of x plus 5 is equal to 15. Now you've usually got two choices when you've got brackets like this. You can either just multiply out the bracket, or you can see if the 4 divides into the 15, and then you could just divide both sides by 4. Now in this case, 15 is not easily divisible by 4, so we're not going to divide through by 4 both sides. Instead we're going to multiply out the brackets. So 4 times x and 4 times 5 to get rid of the bracket. So 4 times x is 4x, 4 times 5 is 20, and that's equal to 15. Okay? So now we've got an expression, well, an equation where I've got x multiplied by a number and then added onto it. So working through BIDMAS backwards, I've got my multiplication, which comes before addition. So if I'm going backwards, I'm going to deal with the adding first and then the multiplying. So the opposite of adding is subtracting. Okay, so they'll cancel, leaving you with 4x on the left, and on the right 15 minus 20. That's going to be negative 5, isn't it? And then 4x is negative 5, so dividing both sides by 4 next, doing the opposite, timesing by 4. I'm going to be left with x equals, well, it's just going to be minus 5 over 4. Now, that's a perfectly acceptable answer. You don't need to turn that into a decimal. You don't need to write as a mixed number. 5/4 is perfectly fine, as long as you can't simplify it down. It's a top-heavy fraction is a perfectly acceptable answer, so I'm just going to leave it like that. Now, with this one though, I was talking about brackets earlier. You've got two choices when you've got these numbers on the front. If the 5 divides into the 35, it's better off just to go ahead and divide it off straight away. So if you divide both sides by 5 here, okay, that will cancel with that, leaving you with x minus 2. And the 35 divides by 5, leaving you with 7. So it's much easier than multiplying out the brackets and then dealing with the two terms. So if you can divide both sides by that number at the front of the bracket, then you should go ahead and do that. It makes it a lot easier. And then if I've got x minus 2 is equal to 7, I just need to add 2 to both sides, cancel in there, giving me x on the left and 9 on the right. X is 9. Part B says solve 9y plus 1 is equal to 6y plus 13. Okay, so now we've got unknowns on both sides. I've got a 9y here and a 6y here. So what I'm going to do is I'm going to take the smaller one of the two, the 6y, and I'm going to take that away from both sides. So we'll just do the smallest one, because then y's will disappear from this side. They'll all disappear, and I'll end up with a smaller value of y on the left. 9y, take away 6y. That leaves me with 3y. So I've got 3y plus 1 is equal to 13. Okay, so now doing BIDMAS backwards, what I've got, I'm multiplying by 3, and then I'm adding 1. So going backwards through that, I'm going to deal with the plus 1 first. The opposite of adding 1 is taking 1 away. So they'll cancel, leave me with 3y, and then 13 minus 1 is 12. And then going to divide both sides by 3, leaving me with y on the left and 4 on the right. Next up, sequences. Question 24, the nth term of sequence is 5n minus 2. Work out the third term. Circle your answer. Well, this is another substitution question, really. For the third term, that just means n is 3, because we number the terms by their position in the sequence. So for the first term, n is 1, second term, n is 2, third term, n is 3. So we're just going to sub n is 3 into that expression. So just like we were doing with substitution, we're going to replace n with the expression with the value 3, and then just work out what it is. So what's 5 lots of 3 minus 2? 5 lots of 3 is 15. Take away 2, that's 13 then, isn't it? It's that one there. 25a says the term-to-term rule for a sequence is add 4, then divide by 2. The first term of the sequence is 36. Work out the third term. Okay, so u1, the first term, we know is 36. And then u2, the next term, is going to be the first term, 36. We're going to add 4, and then we're going to divide everything by 2. Okay? So what's 36 plus 4? That's 40. And 40 divided by 2, that's 20. And then u3, the third term, is going to be my u2 term, 20. We're going to add 4 to it, and then we're going to divide by 2. So what's 20 plus 4? That's 24. And 24 divided by 2, that's 12. So my third term is going to be 12. Okay? This is quite a handy notation, u1, u2, u3, first term, second term, third term. Just make sure the calculations easier to read and people can see what it is you're talking about. So yeah, if you want to adopt that in your work, I think it would be helpful. Part B says the term-to-term rule for a different sequence is divide by 3 and then add 10. The second term of this sequence is 60. Work out the first term. Okay. Well, if you imagine this a little bit like a function machine, so I've got my input value. What am I going to do? I'm going to be dividing by 3, and then I'm going to be adding 10, and then that's my output value then, isn't it? That's kind of what's going on with this. So if we're saying that the second term is 60, work out the first term, because it's a term-to-term rule, it's just basically going through this function machine backwards. So if the output was 60, what was the input to start with then? What was the number that we had that we ended up with 60? So if we're going through this backwards, rather than adding 10 here, before, what did we add on 10 to get 60? Well, if we take that 10 away, 50 add 10 is equal to 60. So it must have been 50 at this point here. And then the step before, a number divided by 3 was 50. What was the number before? Well, 50 times 3, 150 must have been fed into this function. So that when we divided by 3 we got 50, and then when 10 was added I got 60. So if the second term is 60, then the first term must have been 150. Question 26a, the term-to-term rule of a sequence is add 8 and then divide by 2. The first term of the sequence is minus 24. Work out the next two terms. So again, you can think about this as a function machine, if that's easier for you to think about. So we're going to add 8 and then divide by 2. So if our u1, the first term, is negative 24, and we feed that into the function, then u2 then is going to be my value from u1 minus 24, but we're going to add 8 to it, and then we're going to divide everything by 2. So negative 24 plus 8, that is negative 16, isn't it? And negative 16 divided by 2 is negative 8. So the second term is negative 8. So the first term is negative 8. And then u3, the third term, is going to be taking my negative 8, which is my second term, adding 8 to it and dividing by 2. Well, minus 8 plus 8 is 0. And anything 0 divided by anything is still just 0. So my next term is 0. Part B says the term-to-term rule of a different sequence is subtract 1 and multiply by 5. The third term of this sequence is 120. Work out the first term. Okay. So we need to work backwards again. So again, if we had a function where we are subtracting 1 and then multiplying by 5, and we want to kind of go through that function backwards, then going back the other way, look, we're going to be dividing by 5 first, and then we're going to be adding 1, and that's going to get us back to where we started from. So if I take u3 as 120, if I want u2, I'm going to have to work backwards like that, aren't I? I'm going to take my value for u3 and I'm going to divide it by 5, and then I'm going to add 1, and that's going to be my u2 value then, isn't it? So 120 divided by 5, what's that? That's 24 plus 1 is 25. So my second term u2 is 25, and my first term u1 is going to be the same thing. I'm going to take 25, my second term, I'm going to divide it by 5, and I'm going to add 1. 25 divided by 5 is 5, plus 1 is 6. So u1 must have been 6 to start with. So what's the first term? The first term is 6. Question 27a. Here is a sequence: 5, 8, 11, 14, 17, blah, 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 blah. Write down the next number in this sequence. Well, what's going on from term to term here? From there to there, it's got a difference of 3. From there to there, it's got a difference of 3. From there to there, it's got a difference of 3. So this is an arithmetic progression, or a linear sequence is another way of putting it. So we're adding 3 each time. So the next one we're going to continue in the same vein, aren't we? We're just going to add another 3. That's going to be 20. So what's the rule? Well, the next number is 20. What's the rule? It's a plus 3 sequence. We're adding 3 each time. Okay? Here is a different sequence. Work out the nth term of the sequence: 7, 13, 19, 25, 31. Now, what sort of sequence is this? Well, you can see that the difference between there is plus 6, the difference between there is plus 6, the difference to there is plus 6, the difference to there is plus 6. We're adding 6 each time. So I know that the 6 times table, 6n, is equal to 6, 12, 18, 24, 30. That's quite like my number sequence there, except each one of my numbers is 1 less than the numbers in the sequence I've been given. So if I take 6n and I add 1 to it, 6n plus 1, that's going to give me 7, 13, 19, 25, 31 then, isn't it? So my nth term for this sequence, un, is equal to 6n plus 1. Question 28. Here are the first 5 terms of a linear sequence. So it's linear. What's it going up in? So 9 plus 6 is 15, plus 6, plus 6, plus 6. Okay, so again, I know something that goes up in 6s. It's 6n, or the 6 times table. That gives you 6, 12, 18, 24, 30. Now that's a little bit like my sequence I started with. It's going up in 6 like that one is, but I haven't quite got the same numbers. But if I take my numbers and I add 3 to each of them, I get 6n plus 3, which is 9, 15, 21, 27, 33 then, isn't it? So my nth term for this one, un, is equal to 6n plus 3. The next one, this linear sequence, this one's actually going down, isn't it? It's a subtract one. Minus 6, minus 6, minus 6, minus 6. Now I know a sequence that goes down in sixes. It's minus 6n. Minus 6n goes minus 6, minus 12, minus 18, minus 24, minus 13. Now you might be thinking that looks nothing like the sequence that I've been giving up here, but actually it does, because if you add, what's the difference between 46 and minus 6? That's 52. If you add 52 to each one of my numbers, it comes out to be the number from the sequence, doesn't it? So 52 minus 6 is 46. So if I got minus 6n plus 52, that gives me the desired sequence then, doesn't it? Minus 6 plus 52 is 46, minus 12 plus 52 is 40, minus 18 plus 52 is 34, and so on. So here I could write down it as minus 6n plus 52, or I could just spin it around and say un is 52 minus 6n, save myself a symbol, okay, when I write it down. So you can write it down either way. You can write it down as minus 6n plus 52, or you can write it down as 52 minus 6n. Question 30, all the terms of a geometric progression are positive. The second and fourth terms are shown. Okay, so I've got blankety blank 4, blankety blank 16. Now, geometric progression has got a common ratio rather than a common difference. That means that each term is a multiple of the previous one. Okay, so what must it be being multiplied up by if it goes from 4 to something to 16? Okay, well, if I was doubling it each time, that would work, wouldn't I? So if I was multiplying everything by 2, so if I times this one by 2 and I got 8 here, and I times this one by 2, I'm going to get 16. Okay, so that seems to work. And so if that's the case, then going backwards, I must have multiplied 2 by 2 to get 4 then, mustn't I? So what is the first term? It's 2. And what is the third term? It's 8. Now I just did that by kind of trial and error. If 2 wouldn't have worked, I'd try 3, and if 3 wouldn't have worked, I'd have tried 4 until I found the pattern that worked. Okay, yeah, but you're just multiplying through by the same number each time. So yeah, a bit of trial and error was probably the easiest way of going about it. You can do these one sort of thing algebraically, but it would be longer than just kind of trial and improvement in this case. It doesn't say show method or anything, so as long as you got the answers, that is fine. Question 31, match each sequence to its description. So 1, 1, 2, 3, 5, 8, that's the classic Fibonacci sequence. 1, 2, 4, 8, 16, 32. Now these are doubling each time or multiplying by 2, so similar to the last question, this is a geometric progression, isn't it, where you've got a common ratio. 1, 2, 3, 4, 5, 6, this is a +1 arithmetic progression or linear sequence, isn't it? So this one is this one up here, arithmetic progression. 1, 3, 6, 10, 15, 21. I don't know if you recognize these. It's a good idea to remember these sequences. This one is the triangular numbers, isn't it? Okay. Think about 10-pin bowling. Think about playing pool. You have 15 balls in the triangle. Yeah, so you just need to kind of recognize some of these sequences. That's the triangular ones. 1, 4, 9, 16, 25, 30, 36. I hope you recognize that sequence. They're all squares, aren't they? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. They're the squares. And 1, 8, 27, 64, 125. They are cube numbers. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 2 times 3 is 27, and so on. They're the cubes. Okay? Question 32. The nth term of a sequence is 12n minus 5. Work out the numbers in the sequence that have 2 digits and are not prime. The nth term of a sequence is 12n minus 5. Work out the numbers in the sequence that have 2 digits, blah, blah, blah. I'm just going to have to generate some terms here, aren't I, and look at them. Okay, so remember I was saying that you just have to sub in a different value of n for each term that you want. So for when n is 1, 2, 3, 4, 5, 6, what am I going to get? I don't know how far I need to go. I'm just going to get some values and see what I get, and then I can think of it from there. Okay, so 12n minus 5 is the rule. So take the value of n, 1, times it by 12, 12, take away 5, that's 7. So 1 comes into this, 7 comes out. Okay, when n is 2, 12n minus 5, 12 lots of 2 is 24, take away 5 is 19. When n is 3, 12 times 3 is 36, take away 5 is 31. When n is 4, 12 4s are 48, take away 5 is 43. And 5 12s are 60, take away 5 is 55. 6 12s are 72, take away 5 is 67. Right, so what am I trying to do? I'm trying to find numbers that have 2 digits, work out the numbers in the sequence that have 2 digits and are not prime. Okay, well, better go up a bit higher because I think I might have some more beyond there. So I might have to do a few more. So what's the 7th one? 7 12s are, what did we say? We're up to 84, aren't we? Take away 5 is 79. And then the next one after that, well, it's just going to be 12 more each time, isn't it, really? So the 8th term is going to be 91. And then after that, it's going to be bigger, isn't it? It's going to be a 3-digit number after that. So I don't have to worry about anything beyond there. That's as far as I need to worry about. Okay, so it's definitely not this one. This one is too small. It's not a 2-digit number. Okay, so it's going to be the numbers 19, 31, 43, 55, 67, 79, 91. But we need to remove the ones that are prime. Okay, so which one of these numbers are prime? 19 is prime, and get rid of that. 31 is prime, can get rid of that. About 43. I think 43 is prime. I think we're going to get rid of that. 55 is good because it's got 11 in it. 11 5s are 55. 67, is 67 prime? Yep, I think it is. It's a good idea to remember your primes up to 100 for this exam. A bit like triangle numbers, square numbers, cube numbers, your prime numbers up to 100. It's kind of handy for these sorts of questions. 79 is also prime. 91 is not prime. It's actually 7 times 13. So those two numbers are the only not prime numbers that are in that sequence. So that I've got 2 digits, so they're my answers. So it's going to be 55 and 91. Next up, percentages. This is going to be percentages without a calculator, isn't it? So it's all going to be about chunking and finding easy percentages that we can then chunk together to find what the ones we're looking for. So like 50%, 10%, 5%, 1%, and then kind of piecing those together to find the answer. So if I've got 100% of something, be it equal to 14,000, 10% of that something is going to be 1,400, isn't it? Okay, and then another 10% is going to be also 1,400. So 20%, that's going to be those two added together, then, isn't it? So adding those up, that's 2,800. That's my answer. Okay. I'm going to do something similar here for working out 80% of 300. I'm going to start off with the fact that 100% is equal to 300. Now to find 80%, there are different ways of doing it. I could find 20% and subtract it from 100%. I think that might be the easiest way. Or I could do 50%, 10%, 10%, 10%. Okay, either way is fine, but I think finding 10% and deducting it twice from 300 might be the easiest way. So 10% is going to be 30. So if I take 2 of those and subtract it from 100, that's going to leave me with 80%, isn't it? Okay, so 2 lots of 30 is 60. So 300 taken away from 60, that is 240. Okay. So like I say, we're just going to find easy percentages and either add or subtract them with each other to find the amount we're looking for. So if I want to find 51% of 400, so 100% is 400. So 50% is going to be half of 400, isn't it? It's going to be 200. 10% would be a tenth of 400, be 40, and 1% is going to be a tenth of that, it's going to be 4. So if I want to make 51%, I want that one and I want that one added together, so the 200 and the 4, that gives me 204. What is 70 out of 200 as a percentage? Well, 70 over 200 as a fraction is that. If I can get it as a fraction over 100, which I should be able to do by dividing top and bottom by 2, because 200 divided by 2 is 100. 70 divided by 2 is 35. That's 35 out of 100 then, and that's the same thing then as 35%. B, work out 0.5% of 920. 100% is equal to 920. 10% is going to be a tenth of that, that's 92. 1% is going to be a tenth of 92, which is 9.2. And then 0.5% is going to be half of 10%. Well, so what's half of 9.2? Well, half of 9 is 4.5. Half of 0.2 is 0.1. So 4.5 and 0.1 is 4.6, isn't it? So 4.6 is half of 9.2. And that's my answer then. It's going to be 4.6. Question 37. 5% of a number is 31. 1% of the same number is 6.2. Work out 13% of the number. Well, how can I build 13% with those building blocks? I've already been given them, so there's no point in finding any more. Let's just use 5%, 5%, 1%, 1%, and 1%. That adds up to 13%, doesn't it? So just using the blocks they gave me. So that's 31, 31, 6.2, 6.2, 6.2. Put point zeros on there so I can add them up nicely. So I've got 0.0222, that adds up to 6, and I've got 11666, that's 20, isn't it? So that's 0 carried 2, and then 233, that adds up to 8. So my answer is 80.6. Question 38, 10% of 2,100 is 210. Work out 43% of 2,100. Okay, so I want to get 43, so I could use 10%, 10%, 10%, 10%. I could also just multiply it by 4 if you prefer adding up, multiplying by 4. Yeah, not much in it. And then if I got 1% and 1% and 1%, I can add all those up. It's quite a long list, isn't it? That's going to give me 43%. So what is 10%? Well, we know it's 210. So 210, 210, 210. And then 1% is going to be a tenth. That's going to be 21, 21, and 21. So adding all those up, first column 0, 0, 0, 0, 1, 1, 1, that adds up to 3. Second column, we've got 1, 1, 1, 1, that's 4 ones there, that's 4, and then 2, 2, 2, that's 6, that adds up to 10, so that's 0 carry 1 again. So then I've got 2, 4, 6, 8, and the 1 makes 9. So I make that 903. Question 39. The usual price for that jacket is £65. The sale is 15% off the usual price. Work out the sale price. Okay, so 100% everything is 65. We want to work out 15% and take it off, don't we? Because it's 15% off. So what's 10%? That is £6.50, and then 5% is going to be half of that. That's going to be £3.25. Okay, so then 15% together, £6.50 and £3.25. That adds up to £9.75. And so £65 minus £9.75. Well, £65 minus £10 would be 55. So what we'll do, we're taking 15% away, and that will give us 85%, won't it? That's what we're finding. And so taking £10 off 65 would be 55, and then adding a 25p back on again. That's £55.25. Okay. Question 40, increase 6,800 by 12%. So again, if 100% is 6,800, then 10% is equal to 680. 1% would be a tenth of that, would be 68, and another 1% would be another 68. So if I add all of those together, including the 100%, that's going to give me 112%. So we've got 100%, we've increased it by 12%, we've got 112%. So doing the maths on the other side, 0, 0, 8 and 8 adds up to 16. So 6 carry 1. I've got 6, 12, 20, 21 then on that side. So that's 1 carry 2. I've got 2, 8 and 6 adds up to 16. So 6 carry 1 and 1 and 6 makes 7. So I make that 7, 6, 1, 6. Next up, we've got laws of indices, and we're going to be making use of the following rules. If I've got two numbers with the same base, but with indices, and I multiply them together, then same base, index, index, then we add those indices together, don't we? So a to the n times a to the m is a to the n plus m. Okay? Then we've got one for dividing as well. So if I've got a to the n and I divide it by a to the m, then I'm going to be, got same bases, I'm going to subtract these indices, then aren't I? So n take away m is going to be the solution to that one. So that's a to the n minus m. And then finally, the last rule that we need to remember is if I've got a number with a power and then I raise it to another power, then I'm going to be multiplying those indices together. So a to the n raised to the power of m is going to be a to the power of m times n. Okay? So these are like the three rules that you need to remember and be able to apply to these questions to answer them correctly. So first up, we've got question 41. It's simplify 2 to the 5 times 2 to the 3. So you can see I've got two numbers with the same base, 2 and 2, and I've got indices on both of them, and I multiply them together. So our first rule over there says we need to add the indices. So 2 to the 5 times 2 to the 3 is going to be 2 to the power of 5 plus 3. That's 2 to the power of 8, isn't it? It's that one there. Question 42. Simplify 5 to the power of 4 all squared. That's my third rule, isn't it? I've got a number with a power and I'm raising that to another power. So what we do is we multiply those powers together. That's going to be 5 to the power of 4 times 2. 4 times 2 is 8, so that's 5 to the power of 8. It's that one. Question 43, a to the power of 20 times a to the 5. I've got two numbers with the same base. Going to multiply them together, so I'm going to add those indices together. That's going to be a to the power of 20 plus 5. That's a to the power of 25, isn't it? A stays the same. Add the indices, you're going to get 25. B, simplify a to the 20 divided by a to the 5. Two numbers with the same base. I've got indices 20 and 5. I'm going to subtract them here, aren't I? So I'm going to get a to the power of 20, subtract 5. That's 15. So I'm going to get a to the power of 15. Part C, a to the power of 20 raised to the power of 5. So I've got a number with an index and I'm raising that to a power. So what I'm going to be doing is multiplying those indices, those powers together, aren't I? That's a to the power of 20 times 5, which is 100, isn't it? So a is my base and 100 is my power. Question 44, work out 3 to the 12 divided by 3 to the 7. Give your answer as a whole number. Okay, so two numbers with the same base, 3 and 3. So I'm going to be subtracting these indices from each other when I divide them through. So 3 to the 12 divided by 3 to the 7 is going to be 3 to the power of 12 minus 7. That's 3 to the power of 5. Okay, now if I want to give that as a whole number, I'm going to have to work that out then, aren't I? So what is 3 to the 5? Well, I know 3 squared is 9. 3 cubed is 27. So 3 to the 4 must be 27 times 3, which is 81. So 3 to the 5 must be 3 lots of 81. So what's that? 80, 160, 240, and 3. It's going to be 243. Okay. Question 45. Work out the value of 3 to the power of 12 divided by 3 to the power of 5 divided by 3 squared times 3. This looks pretty horrible, but I think we're just going to take it part by part. So we're going to start with the left-hand bracket. I've got two numbers with the same base. I'm dividing them, so I'm going to be subtracting those indices from each other then, aren't I? So 3 to the 12 divided by 3 to the 5, that's going to be 3 to the power of 12 subtract 5, that's 3 to the power of 7. And I'm going to be dividing that by the contents of the next bracket. Now here I've got, again, numbers with the same base. So, and I'm multiplying, so we're going to add the indices together. Now this second 3 doesn't have an index, but that just means the index is 1, isn't it? If you just got a number by itself, it's got a power of 1. So it's going to be 3 to the power of 2 plus 1. That's 3 to the power of 3 then, isn't it? Okay. So now I've got two numbers with the same base, 3 and 3. This time I've got an index of 7 and an index of 3, and I'm dividing them, so I'm going to be subtracting those indices. So that is going to be 3 to the power of 7 subtract 3, which is 3 to the power of 4. And again, it's asking me to work out the value, so I need to then go on and work out what that is. I can't leave an index form this time. So 3 to the power of 4 is 3 times 3 times 3 times 3, which is 81. Moving on to inequalities, question 46a says write down all the integer values that satisfy minus 3 is less than or equal to n, which is less than 2. Okay. Now imagine a number line with those numbers on it. I'm just going to use the line they're giving me because it's quicker than drawing a line. Minus 3, minus 2, minus 1, 0, 1, and then 2. They're all the numbers between minus 3 and 2. Now our value of n, it can be equal to minus 3 because it says n can be greater than or equal to minus 3. But it can't be equal to 2, but it can be equal to any of those other numbers in between. So it can be any of those, but it can't be 2 because n has to be strictly less than 2. So the integer values is the whole number values between those two limits. Okay. If you were drawing this as a diagram, you'd have a circle here, and a line in between. This one would be filled in because you're allowed to be equal to minus 3, and the other one would be open because you aren't allowed to be equal to 2. So the integer values that satisfy that range are just going to be minus 3, minus 2, minus 1, 0, and 1, and definitely not 2. Part B says show 2 is less than x, which is less than or equal to 10 on the number line. So doing the same thing, drawing a circle at 2, drawing a circle at 10, drawing a line that joins them up, missed. Drawing a line that joins them up, drawing a line that joins them up, okay. So that's almost done. We just need to fill in or not fill in the circles. If it can be equal to the number, you fill it in. If it can't actually be equal to the number, you don't fill it in. So on the right hand, x is less than or equal to 10. That means I can fill in that one on that end. But I can't fill in the other end because x needs to be strictly greater than 2. So it looks like that. 47a says show the inequality x is greater than minus 2 on the number line. Okay, so similar thing. I'm going to have a circle at minus 2. Now I haven't got another circle it joins up to. So just in this one, I'm just going to have a line that's infinitely going on off the end of the line. I'm just going to draw an arrow and it continues in that direction. Okay. Do I fill in that O there? No, I don't, because x needs to be strictly greater than negative 2. So open circle at minus 2 and an arrow pointing off to the right. Part B says solve the inequality 3x plus 5 is less than or equal to 11. Now we just did a whole bunch of solving equations earlier. This is just the same. It's the same skill. Okay, the only difference is I've got an inequality in between them rather than an equation. Again, we're going to be using BIDMAS backwards to use these inverse operations to unwind the inequality and get us back to x. Okay, so here I've got a multiplication and I've got an addition. Multiplication becomes before addition in BIDMAS, so working backwards through BIDMAS, I'm going to deal with the add 5 before I deal with the multiply by 3. So the opposite of adding 5 is subtracting 5, so if I subtract 5 from both sides of my inequality, they'll cancel and it will leave me with 3x on the left, and that's less than or equal to 11 take away 5, that's 6 on the right. Okay. Next up, I'm going to deal with the 3x by dividing both sides by 3. They'll cancel, and it will leave me with x is less than or equal to 2. And that's my final answer. X is less than or equal to 2. 48a, solve 4x minus 7 is less than or equal to 13. Again, I've got a multiplication and a subtraction this time. So again, using BIDMAS backwards, I've got a multiplication, I've got a subtraction. I'm going to deal with the subtraction first, aren't I? So the opposite of subtracting is adding. add in 7 to both sides, they're going to cancel. That's going to leave me with 4x is less than or equal to 20. Dividing both sides by 4. That's going to leave me with x is less than or equal to 5. 5. X is less than or equal to. Right, show 3 is less than x is less than or equal to 8 on the number line. So 2 circles, one at 3, one at 8. Join them together with a ruler. Decide if you have to fill in the circles or not. I don't fill in 3 because x needs to be strictly greater than 3. I do fill in 8 because x is less than or equal to 8. So filled circles means it can be equal to that one. Question 49, solve 5 lots of x plus 3 is less than 60. Now, similar to when I was doing the equations earlier, if I've got a number outside a bracket like this, you've got 2 strategies that you might employ. You might multiply out the bracket, but if that 5 divides into the 60, which it does in this case, it's just much quicker just to get rid of it by dividing both sides by that number to start with. So dividing by 5, that's going to give me x plus 3 on the left, and that is less than 5 into 60, which is 12. And then subtracting 3 from both sides, subtract 3, they'll cancel, and that will leave you with x is less than 9. Now if you do multiply out the brackets, you'll still get the same answer. You'll just take you longer because there's more steps. Okay. Question 50. Again, we looked at this when we were looking at solving equations. I've got unknowns on both sides here, 5x and 3x. So the first step is just to get rid of one of the unknowns. Take the smaller one of the two and subtract that from both sides. That will have the effect of getting rid of one on one side and reducing the size of the other one. So that's going to give me 2x on the left. I've still got the plus 6 because I haven't done anything with that yet, and that's greater than 15 because I haven't done anything with that yet. Okay, so now I need to just simplify 2x plus 6 is greater than 15. Thinking about bid mass backwards. So what's going on here then? So I've got a multiply by 2 and then an add 6. So I've got a multiplication and an addition. So going through bid mass backwards, addition first, then multiplication. So dealing with the addition, doing the opposite of adding 6, I'm going to subtract 6. They'll cancel. It's going to leave me with 2x is greater than 15 take away 6 is 9. Then dividing both sides by 2. Divide by 2, divide by 2. Leaves me with x is greater than 9 divided by 2. I could just leave it as 9 divided by 2 if you really want to write it as a decimal. It's 4.5. Okay, either of those answers would have been acceptable. Yeah. Next up, standard form. When you write a number in standard form, it needs to be in the form a plus 10 to the n. Now this number needs to be a number between 1 and 10. So a needs to lie between 1 and 10. Now it can be equal to 1, but it can't be equal to 10. It's like up to 9.99999 whatever. Okay. On the other end, that part's called the mantissa. This part is called the exponent, and that value of n needs to be an integer. N is an integer. Has to be a positive or negative whole number. Okay. That's the rules for standard form. So circle the number that is written in standard form. Well, this one is not, because this is not a number between 1 and 10. Okay. This is not, because this is not an integer. Next one is fine. This one is not, because this is not a number between 1 and 10. So there's only one number in standard form. It's that one. Question 52. Write in standard form 12,500. Okay, so you're going to take the digits of your number 1, 2, 5 and write those down, and you're going to plonk the decimal point somewhere in that number so it ends up between a number between 1 and 10. So the place it needs to go is there. Okay, now 12,500. There's two ways of thinking about this. You can either think about how far has the decimal point shifted. So it was here and it's gone 1, 2, 3, 4 jumps to the left. So that means it's times 10 to the 4. That's one way of thinking about it. Another way of thinking about it is this number is the magnitudes of tens of thousands. So if you think about powers of 10, you've got 1, which is units, you've got 10, which is tens, you've got 10 squared, which is 100, you've got 10 cubed, which is 1,000, and then you've got 10 to the 4 is tens of thousands. So you can just kind of remember what magnitude each of these numbers are and just write down that. That's a different way of doing it. Okay, write down as an ordinary number 3.4 times 10 to the minus 2. Now this is a very small number, isn't it? The exponent is minus 2 here. So what I do with these, when it's a negative exponent like that, I know there are going to be 2 zeros in my number. So 0.0 is my 2 zeros, 1, 2 zeros, and then I just write the mantissa part down. So the digits from here I then write after those zeros, so that's going to be 3, 4. Okay, so you look at the exponent part to know how many zeros there are. Write those down first and then just kind of fill in your digits from the mantissa after that. 0.034. Right, question 53. Write 9.2 times 10 to the minus 3 as an ordinary number. Again, negative 3 means I'm going to write down 3 zeros. 0.00, then my 3 zeros, 1, 2, 3. One always appears in front of the decimal point and the rest are after. And then after that I'm just going to write my digits down, 9 and 2. So 0.0092, like that. 54A, write the number 0.000007 in standard form. So I'm going to do the opposite of what I just did then. I'm going to count the number of lead zeros in. 1, 2, 3, 4, 5, 6, 7. So my number is going to be times 10 to the minus 7. I know that already. And then I've got that 7. I'm just going to write the digits down after that. So at the front, that's my mantissa part. So it's going to be 7 times 10 to the minus 7. So the minus 7 comes from the fact there are 7 zeros, and the 7 comes from the fact that it had a 7 in it. Okay, write 3 times 10 to the 5 as an ordinary number. So this is a positive index. So when it's 3 times 10 to a positive number, you can write your 3 down, and then you're going to write that amount of zeros following it. It's going to be 0,0,0,0,0, and it's 300,000. Part C says work out 4 times 10 to the 3 times 8 times 10 to the 5. So I've got two numbers in standard form multiplied together. Now when this happens, the easiest thing to do is to multiply like with like. So multiply your mantissas together, multiply your exponents together. So 4 times 8, what's that? 4 8s are 32, isn't it? So I'm going to multiply those two together first, give me 32. And I'm going to multiply 10 to the 3 times 10 to the 5. So the laws of indices say same bases, add the indices. 10 to the 3 times 10 to the 5 is 10 to the 8. Just add in the 3 and the 5 together. Okay, so I've got 32 times 10 to the 8. Now that's not quite in standard form because the 32 is not a number between 1 and 10. Okay, but if I change that to 3.2 times 10, and then I take that 10 and I roll it into my 10s that I've got at the end. I've got 10 to the 8, which is basically 10 times 10 times 10, 8 times. So if I take 10 out of the 32 and roll it in with the 8 10s I've already got, then I'm going to have 9 10s. It's going to be 10 to the 9. Okay, so I kind of take a 10 out of the mantissa, or what was going to be the mantissa, and then I'm going to add it into the exponent part. Okay, increasing it by 1. So my answer is 3.2 times 10 to the 9. Work out 2,000 times 70,000. Now I'm going to start by multiplying the digit parts together. 2 times 7, that's 14. And then I've got 0, 0, 0, 0, 0, 0, 0. What's that? 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. So that's thousands, millions, that's 140 million. Okay. Now what's that number in standard form? Well, the decimal point is going to go between the 1 and the 4, isn't it? I'm going to get 1.4 as my mantissa part, and then what's the power of 10? So if the decimal point starts here and jumps 1, 2, 3, 4, 5, 6, 7, 8 jumps to the left, that would be 1.4 times 10 to the 8 then, won't it? Okay. Last up, let's have a look at calculating in terms of pi. So often we're going to get asked shape and space questions involving circles, and whenever we do, we're going to end up with pi turning up somewhere in our calculation. Now, without a calculator, that's going to be hard to evaluate, isn't it? Because like pi is 3.1415, etc. Okay, so rather than doing all that long multiplying at the end of every question involving pi, often the question asks you to give your answer in terms of pi, like this one does, give your answer in terms of pi. So that just means you get as far as you can with pi in it and then you stop. Okay, so the diagram shows a semicircle of radius 8 centimeters. Work out the area of the semicircle. Okay, well, a semicircle is made up of two parts. It's got this curved part that goes along here, and it's got this straight section that runs down here. So if you want to work out the perimeter, you need to work out those two lengths and you need to add them together. Okay? Right, so let's have a look at the curved part first. The curved part is part of a circle. Now the perimeter of a circle circumference is equal to pi d, or sometimes it's written as circumference equal to 2 pi r, because 2 radius is the same thing as the diameter. I actually think this one would be slightly easier to use in this this version, because I've got half a circle. It lends itself to be halved a bit easier. Okay, so I'm going to use that one. So I'm going to use the fact that that yellow line there is half of 2 pi r. Okay, half the circumference of a circle. And then I need to add on the green part. The green part is 2 radii, isn't it? So I'm going to add on our 2 radiuses. So this is the expression for the yellow part. This is the expression for the green bit. Okay, so subbing in our values, that's going to be a half times 2 times pi times, what's the radius? It's 8. Okay, and then plus 2 times 8. Okay, so half times 2, they're going to cancel each other out, aren't they? Half of 2 is just nothing. And then I've got pi times 8, which is 8 pi. And then I've got 2 times 8, that's just 16. So that's as far as I can get. Now I could, if I knew what pi was, I had my calculator, I could type that in and get a kind of a rounded off version of what it was. But in the exact form, in terms of pi, that's as far as we need to get, 8 pi plus 16. Question 57 says work out the area of the semicircle of radius 6 centimeters. Give your answer in terms of pi. So area of a circle is given by pi r squared, but I haven't got a circle here. I've got a semicircle, it's half a circle. So the area of this shape is going to be a half of pi r squared then, isn't it? Okay, that's the formula I'm going to be using here. So subbing in what I know, so that's going to be a half times pi times 6 squared then, isn't it? 6 squared is 36, half of 36 is 18. So altogether that is 18 pi. Question 58, here's the quarter circle of radius 6 centimeters. Work out the area of the quarter circle, give your answer in terms of pi. So this time the area is going to be a quarter of pi r squared, because it's a quarter of a circle. Okay, so subbing in what we know, a quarter of pi times 6 squared. 6 squared is 36. A quarter of 36 is 6, 4 is into 36. That goes 9 times, doesn't it? So a quarter divided into 36, or 36 divided by 4, that's 9. So the answer is going to be 9 pi. Question 59, the semicircle has a radius of 5 centimeters. Work out the perimeter of the semicircle. Give your answer in terms of pi. So exactly the same as the last one. The perimeter is going to be given by a half times 2 pi r. They're going to cancel off. Half and 2 just cancel out, so it's going to be basically pi r, isn't it? Plus the 2 radii, the radius and the radius. Okay, so this is the expression for this part, and this is the expression for this part. Okay, so subbing in what we know from the diagram, so the half and the 2 have cancelled, so basically it's just pi times the radius, is pi times 5, and then plus 2 lots of 5, because 5 is also the radius. So pi times 5 is 5 pi, 2 times 5 is 10, so my final answer is 5 pi plus 10. Question 60, here is a circle touching a square. The area of the square is 64. Work out the area of the circle. Give your answer in terms of pi. Okay, so I've got a square, it's got an area of 64. Now you find the area of a square by multiplying the length and the length together. So that means that my length squared is equal to 64. So if I want the length, I need to square root 64 in order to find it. So what is the square root of 64? Well, 64 is 8 times 8, isn't it? So the square root of 64 is 8. Okay? So I know the square root is 8. So I know then the length of this square is 8. That's 8 and 8. But what we need to know for the area of the circle is the radius. The diameter is going to be 8 as well. But the radius is going to be half that, isn't it? It's going to be 4. Okay, so 4 is the radius of this shape. So the area of a circle is just given by pi r squared. And we've just worked out that the radius is 4. So that's pi times 4 squared. 4 squared is 16. So that's 16 pi. Okay, so leaving it in terms of pi, that's it. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.